If A is the 2 by 3 matrix with entries 3, 1/2, 5, 1, -1, and 3, and B is the 2 by 3 matrix with entries 2, -5/2, 0, 0, 2, and -3, compute the following: 1/2 A minus 1/2 B and 10A minus 5B. We'll start by looking at 1/2 A minus 1/2 B. And there's actually two different ways to do this problem. We'll start by doing it directly by multiplying each of these matrices by 1/2 and adding the results. I'm just going to rewrite this problem with the actual matrices written out. All right. So first, we need to multiply each of these matrices by 1/2, and the way that we do that is by distributing that 1/2 to each of the entries in the matrix. So for this first one, 1/2 times 3 is 3/2. 1/2 times 1/2 is 1/4. 1/2 times 5 is 5/2. In the bottom, we get 1/2, -1/2, and 3/2. Then we have minus 1/2 times the second matrix. When we multiply each of those entries by 1/2, we get 1, -5/4, 0, 0, 1, and -3/2. Once we've done this, we can then subtract the matrices entry by entry. So when we do that, we end up with 3/2 minus 1 gives us 3/2 minus 2/2, which is 1/2. 1/4 minus -5/4 is the same as 1/4 plus 5/4, which is 6/4, which ends up being 3/2. Then we have 5/2 minus 0, which is 5/2. In the next row, 1/2 minus 0 is 1/2. -1/2 minus 1 is the same as -1/2 minus 2/2, or -3/2. And then 3/2 minus -3/2 is the same as 3/2 plus 3/2, which gives us 6/2, which gives us 3. So this is one way to do the problem, but there is in fact another way. When we have 1/2 times A minus 1/2 times B, we can rewrite this as 1/2 times the difference A minus B. There is a distributive property when we're dealing with adding and subtracting matrices that says that if we have a scalar multiple out front being multiplied by a sum or a difference, we can distribute that to each of the terms, to each of the individual matrices, and we can do the exact opposite here, and instead of multiplying each of them individually by 1/2 and then taking the difference, we can take the difference first and then multiply them by 1/2. So first we need to find the difference, A minus B, and to do that we just need to subtract each of the terms pair by pair. We actually already did this in the first problem of this section, so we're just going to do it very quickly again. 3 minus 2 gives us 1. 1/2 minus -5/2 is 6/2, which is 3. 5 minus 0 is 5. 1 minus 0 is 1. -1 minus 2 is -3. And 3 minus -3 is the same as 3 plus 3, which is 6. Once we've taken this difference, we can now multiply the 1/2 into the matrix by multiplying each of the entries by 1/2. When we do that, we get 1/2, 3/2, 5/2, and then 1/2, -3/2, and 1/2 of 6 is 3, which is the exact same answer as we got the previous way, but this way uses less work. So either way will work. For the next problem, 10A minus 5B, Unfortunately, we can't use the distributive property to simplify things here because each of these matrices has a different coefficient in front of it, so we simply need to go through the process of multiplying and then taking the difference. So we've got 10 times A, which I will write out, minus 5 times B, and first we're going to multiply these scalar constants inside, and then once we've done that for each, we can take the difference. When we multiply each of the entries in the first matrix by 10, we get 30, 5, 50, 10, negative 10, and 30. When we do the same for the second matrix, but multiplying by 5, we get 10, negative 25 halves, 0, 0, 10, and negative 15. And then when we subtract these matrices entry by entry, 30 minus 10 is 20. 5 minus 25 halves, we'll do that one at the end just because that one requires a little bit more work. 50 minus 0 is 50. 10 minus 0 is 10. Negative 10 minus 10 is negative 20. 30 minus negative 15 is the same as 30 plus 15, which is 45. The only entry that requires a little bit of work is this one right here. So we've got 5 minus negative 25 halves. We know that subtracting a negative is the same as adding a positive, and we want these to be fractions. So 5 over 1 plus 25 halves. The LCD is 2, so this becomes 10 halves plus 25 halves, which gives us 35 halves in the end. So this is the resultant matrix for the problem 10a minus 5b.